Hello friends, welcome to chapter 4. We are going to be studying parabolas, and I have no idea why I don't have any tools on my Notability. Oh, because they're hiding over here. Wow, I'm not that smart. So before we start talking about parabolas, I want to remind you of what they are, graphing parabolas in standard form. We're going to learn a couple different formats. And the key to a quadratic or a parabola is that you are going to have an x squared in your equation. And a parabola is going to open up like that, or it can open down like that. And so a parabola is going to be like f of x equals, and it's going to have an x squared. Or you might just see it as y equals x squared. So somewhere in your problem, you're going to end up with x squared as the highest power. So parabolas have certain features. This point where it changes directions, whether that's at the bottom or the top, that's called the vertex. And the vertex is going to be one of the key points that you have to find. Sometimes that is the minimum. And that's going to happen if it opens up. Like in the picture right above here, the vertex is at the bottom because the parabola opens up from there. Or it can be the maximum. And that is when your parabola opens down. Because as you can see the picture right here, if your parabola opens down, the vertex ends up at the top. So keep in mind that your vertex is going to be written as an x, y coordinate. Axis of symmetry is exactly that. It is a vertical line. Keep in mind that all vertical lines are going to have an x equals some number, and it goes through the vertex. So it's going to have an equation of x equals, and then I'm going to write v sub x, and that's going to be the x coordinate of the vertex. You can look at the chart that I'm going to post too if that helps you organize all the information. But let's go back to this. The vertex can be thought of as an x coordinate of the vertex and a y coordinate. So in my pictures, I would have this vertical line coming down through, and what it means is that you can fold that parabola over that line and it will match up the symmetry, axis of symmetry, line of symmetry. Every parabola will eventually cross the y-axis, and so that's going to be just like it was when we did mx plus b, that b was our y-intercept. We aren't going to have the same setup for the equation, obviously, because it's not linear anymore, but the y-intercept is going to be where the parabola crosses the y-axis, and then keep in mind that that's going to mean there's going to be a 0 for x and then some number for y where it crosses. Also, you can only have one of these. You couldn't have two because then your parabola would be crossing a vertical line twice and fail the vertical line test. X-intercepts, this is where it crosses, if it does, because it doesn't have to, it could be floating up above, but where it crosses the x-axis, and because it's a curve, you could have none of these, one of these, or two of these. Let me see if I can just draw a quick sketch up here, how that would happen. I could have a parabola that's kind of floating around up here or opening down from down here, and that would have no x-intercepts. I could have a parabola that's just sitting on, like the vertex is on, or it's hanging down from, and the vertex is on that x-axis, and that would have one x-intercept. Or what happens probably the most often is that it crosses in two places, and that's when you have two x-intercepts. So there could be 0, 1, or 2, and those are going to be written as a number, and then the y is 0 because you don't go up or down. To be on the x-axis, you have to have a y value of 0. So the first form we're going to study is standard form, and that looks like this. You're going to have a number and then an x squared plus or minus a number with a plain x, and then plus or minus a c value. So how do we know if the graph opens up or down? Well, you guys probably know this if you just kind of think about it. We've talked about this with other styles of graph. if you have a positive a, so a is greater than 0, your parabola is going to open up. If you have a negative a out in front of the x squared, that's going to flip your graph over, and then your parabola is going to open down. So opens up is going to be a positive a in front of the x squared. Opens down is a negative a in front of the x squared. All right. How do we find the equation for the axis of symmetry? So once you know your vertex, it's going to be x equals the x coordinate of the vertex, but we need to know how to find that first. So when we go to find the vertex, like the point where it turns around, the x part of that is going to come from the opposite of b over to a, where a and b come from up in this equation, the standard form. So once I know that x coordinate of my vertex, I find the y value the same way we've always found y values, and that is by taking what I have for x and plug in the x value, which is going to be whatever you got with the opposite of b over 2a. So once I find that x part, I plug it into the original equation to get the y part. So I'm just going to plug in whatever you got as your v sub x number, and that's going to tell me the location of the vertex. Since my vertex has to go, since my line of symmetry or axis of symmetry has to go down through the vertex, it has to pass through this number or it won't be going through the vertex. So ultimately what this means is my equation is going to be x equals, and then the opposite of b over 2a. So once you've established that x part of the vertex, you're not doing more math to find the axis. You're simply taking whatever was in the x part of your vertex and making that the number in your equation. Keep in mind that it is an equation because it's a vertical line. How about the y-intercept? Keep in mind that for the y-intercept, if you look up above here, that's where it crosses the the y-axis, and x has to be 0. So the easiest way for us to do that is to plug in x equals 0 to the original equation. But if you go to this equation up here and you put a 0 in for this x and this x, all you're going to have left is c, because a times 0 squared is 0 plus b times 0 is 0. So in this particular form, your y-intercept is going to be 0, and then whatever that c value is at the end, because everything else disappears when you plug in x equals 0. All right. Now, a parabola is a U shape. It can be tall and skinny or wide. It can move up, down, left, right, just like everything else. This is the parent graph. Let's talk about that. If I want to graph the parent graph, I'm going to plug in a couple of numbers. I'm going to plug in these 5 numbers. -2 squared is positive 4, -1 squared, 0 squared, 1 squared, 2 squared, and so on. So I already know the general shape. At -2, I'm up 1, 2, 3, 4. At -1, I'm up 1, 0, 0, 1, 1, 4, 2, 4. So my parabola that just comes down through here and goes back up, that's going to be the parent graph, and that's going to be the one that is just like average size, where a is 1x squared. Then, how do you know if it's going to be narrow or wider? Think about the stuff we've done in the past, like with absolute value graphs. You are going to have it be wider if a is greater than 1. Then, and now keep in mind, positive and negative I don't really care about, because if it's negative, it's just going to be flipped over. But anytime a is greater than 1, this is going to make it wider, because I'm actually teaching you the exact opposite. So if you can measure, think of it as like a measure of steepness. It's not really slope because that's for lines, but if a is greater than 1, it's going to be going up faster. And so that's going to make this narrow. Whereas if I have an a value that's less than 1, and I'm not talking about -2. -2 is technically less than 1, but I'm talking about like the absolute value of that, not whether it's positive or negative, just the value of the number itself. So when that number is less than 1, so say like 2/3 or a half, then that is going to make this wider because it is less steep. Because when a equals 1, that's just the normal parent graph size. So if I were to graph something that had a 2 in front or a 5 in front, those would get really steep. Whereas if I graph something that was a half in front, it would be pretty fat. Let's say that up here in this graph, I was instead graphing y equals 1/2 x squared, then my table would be a little bit different because I'd still have these numbers, but my y's would be half of what they used to be. So instead of a 4, I'd have a 2. Instead of a 1, I'd have a 1/2. Half of 0 is still 0, 1/2, and 2. So if I graphed those at -2, I'd only go up 2. Here I'd be up a half, 0, half, 2. So what would happen here is I'd end up with a wider parabola, kind of scooping out further. I have no idea what I'm doing now. And so that's not going to be as steep. If, last thing, I had done a 2 in front, all my x's are going to stay the same. But my numbers, my y's are now, instead of just x squared, I'm going to be doubling my old answer. So this is an 8 and a 2 and a 0 and a 2 and an 8. So now at -2, I'm up 1, 2, 3, 4, 5, 6, 7, 8. At -1, I'm up 2, 0, 0, 2, and then up here again. So in this case, if I connected my dots, I would have a parabola that is taller and skinnier because it got steeper faster, because a was greater than 1, and this other guy was wide and did not go up as fast because its a value was less than 1. And if it was negative, then it would just flip over. So my red one, if I flipped it over, then I would have had -4, -1, -1, -4. So my initial graph would have been down here instead. So all those changes are the same that we've talked about in the past. A negative out in front flips it over. The value of a can make it wider or narrower, just like it did with the absolute value. Okay, so in these examples, we're going to find the vertex. We're going to graph it. Make sure you show your vertex clearly on your graphs. We're going to find the axis of symmetry and draw that in. We're going to find the y-intercept. Keep in mind that this is going to be x equals some number. This is going to be a coordinate pair. Y-intercept is going to be a point with a 0 and then a y value. And then we're going to reflect the y-intercept to draw the parabola, meaning that's going to give us more points to guide us. So first of all, in this problem, A is 2, B is -8, C is 6. So when I go to find the x part of my vertex, I'm taking the opposite of B, so the opposite of -8, over 2 times A. So I end up with 8 over 4. So the x-coordinate of my vertex is a 2. Great. How do I find the y part? I go back to the original problem and I plug that 2 that I just got in for both of my x-coordinates. So when I do that, I end up with -2. So at +2, -2, I have my vertex. That is the first thing that they want me to find. Now I need to find my axis of symmetry. But my axis of symmetry is a vertical line through the x part of the vertex, so I actually don't have to do any math. I'm just drawing in that I like to do a dotted line, vertical line that's going to be the middle of my parabola. Okay, so did that. Y-intercept, remember, is pretty straightforward because you are going to put a 0 in for all the x's. And when you do 2 times 0 squared minus 8 times 0, all of that is going to be nothing. So I just end up with my c value for my y-intercept, just like we had in our notes, 0c. So on the y-axis, which is this guy, I'm at 0, 1, 2, 3, 4, 5, 6. Now, because this is my line of symmetry in the middle, it means it's symmetrical around that. So this point is 2 to the left. So 2 to the right is going to be its symmetrical partner. And for what I know how to do right now, that's me finding the reflection right now. That's what I just did. I found the matching pair. It's the same distance from the axis of symmetry, but straight across from it. Now I have enough points to like guide me in drawing this parabola. And I drew a terrible parabola, but I'm going to try again. But the reality is if you draw something, you're going to have those key points marked, so it's going to be good. I can see your axis of symmetry. I can see the y-intercept and its partner and the vertex and the line of symmetry down the middle. So then it's just going to be a matter of connecting those dots. And since this had an a value of 2, I'm not surprised to notice that it goes up, opens up, and that it also is a little bit more narrow. Okay, so just trying to see how many examples we have here. Now I'm going to go ahead and try this again. A is going to be whatever's in front of the x squared, so -1. So thinking about what that's going to mean, my graph is going to open down or face downward. So to find the x part of my vertex, I take the opposite of b over 2 times a. I get -6 over -2, so 3. So the x part of my vertex is a 3. The y part of my vertex is what I get when I plug 3 back into the original equation. And when I plug 3 into all of that, I get a 1. So the first thing I can put on my graph is at 1, 2, 3, 1, I have a vertex, keeping in mind that this should open down when I'm done. My axis of symmetry is going to be very straightforward. I don't need to do any math. It's a vertical line located at the x part of my vertex. So x equals 3. And I draw a vertical line coming right down through that through that vertex. Okay, then y-intercept. Y-intercept, super easy peasy. I'm plugging in zeros, but it's always 0c in standard form. So since my c value is -8, my y-intercept is at 0, -1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to find its partner. So since that's 1, 2, 3 to the left of the axis, I go 1, 2, 3 to the right and draw its partner right across, or its reflection. So then when I go up through here, hit the vertex, turn around and come back down, now I'm looking at what I expected, a parabola that's opening down because it was negative. It's not really wide or narrow because it was a 1. So the value of my